Determining normal probability. So we can use a graphics calculator, as I said before, to find probabilities of it being 1, 2, 3 standard deviations from the mean. So x is a standard normal variable. And if x is a standard normal variable, this means that, so if we're talking about a standard normal variable, that means, and you've got to memorize this, that the mean equals 0 and the standard deviation equals 1. So if you hear standard normal variable, think that we're talking about mean equals 0, standard deviation equals 1. And we can then use z values to determine the probability that it's between -1 and 2.5, or that z is greater than 1. So one thing to note is when you're doing, because you're using norm CDF, the graphics calculator only does calculations with it in less than. So you have to convert it to probability of it being less than C, even if you're given greater than C, such as question 2. And so you have to minus it from 1 initially to get it to that format. So here, if we're finding the probability that Z is between -1 and 2.5, well, to do that, we first of all find the probability that Z is less than 2.5 minus the probability that Z is greater than 1 equals 0.938 minus 0.1587. How I calculate those probabilities is using the calculator, but you also have to memorize them. Not yet, not now, but in the final lecture, we're going to go through the values you've got to memorize, the final lectures being the end of the year, so not yet, and then you would work it out. Yeah, and that's just because we're trying to, so we find the probability it's greater than 2.5 minus the probability it's less than 1, and that gives us this value. Okay, probability of z being greater than 1, well, because it's the inverse, again, it's got to be less than. We get 1 minus the probability of z being less than 1, which equals 1 minus 0.8413 equals